Hi, everyone. Welcome to this discussion session of our monthly Inference Colloquium series. And for those of you who are joining us after yesterday's lecture, as you know, this session serves as a forum for conversation between our speaker and a conversant, which we all witness, share, and ask questions to clarify, to expand and extend the remit of the lecture. So we were really deeply honored, and it was a privilege to listen to Eric Winsberg talk yesterday about causal inference in complex nonlinear systems, a cautionary tale. So I would like to briefly remind you all first that since we are recording this event, that all participants must mute their videos. And as always, please feel free to start typing in your questions into the chat, and we will pick them up right after Eric and our wonderful conversant today, Stephanie, have concluded their own sort of discussions. So we are utterly delighted, and it's a real honor to have Dr. Stephanie Harvard, who is Michael Smith Foundation Health Research Postdoctoral Fellow at the University of British Columbia and the Faculty of Pharmaceutical Sciences there. She received a PhD in Population and Public Health in a joint program between the University of British Columbia and the Université Pierre-Marie Curie in Paris. Well, what a lovely combination of cities, Stephanie, in 2017. Her current focus, research focus, is on the implications of philosophy's values in science literature for health economics modeling and knowledge translation. And her postdoctoral work, current work, focuses on creating educational videos to communicate the role of social and ethical values in modeling and exploring new ways of informing health economics models to patient and public values. She also co-leads a project, a novel mechanism to support transformative model interrogation in patient-oriented health economics, which is funded by the BC unit, Health Economics Unit and Simulation and Methods Cluster. She also happens to be the co-author with Professor Winsberg of the representational risk paper, which on his talk page, which is on, and you can see that that article actually on our talk page on the Inference website. And so together they have also co-authored an earlier paper on public participation in health modeling design. And you might see in just a minute, if I remind you of Professor Winsberg's research interests, and briefly tell you a little bit about what he presented yesterday, how apt a conversant Stephanie is for the work that was discussed yesterday. As you all know, Professor Winsberg is a historian and philosopher of science, and he has been interested in the philosophy of climate change, philosophy of physics, and more generally, broadly, philosophy of science, but in particular, the role of computer simulations and modeling in the physical sciences. His work in the philosophy of climate science relates to the application of models and simulations to science policy and ethics. So his work has always been trying to see how scientific models are used to inform policy decisions. And of course, over the last several months, Eric had enormous bounty in terms of research project falling into his lap from multiple directions, which is the pandemic and the associated data, policy responses to it, and just the way in which the pandemic outcomes, how they have unfolded. So he talked to us about the work that he's done using models and methods of causal inference in the unfolding COVID-19 pandemic. And in yesterday's talk, he demonstrated our blind spots in how we leap to inferring causality and how our directions of inquiry and how we use the data to inform the kinds of judgments and value assessments that we want to make, that in turn shape or are intended to shape public behavior. So without much further ado, Stephanie, I invite you to start this discussion session.
Okay, thank you so much, Priya. I'm going to share my screen. And I'm just going to double check that I'm able to advance. Okay, great. Okay, so like Priya said, this is a conversation today about Eric Winsberg's talk from yesterday, which was called Causal Inference in Complex Nonlinear Systems, a Cautionary Tale. So for future viewers who haven't seen that talk, can go and access that on YouTube for the full details. For my discussion today, I'm going to follow the standard 2-segment format for this talk series. So the first is the in other words segment, where I'm going to give you the gist of what I think Eric was saying yesterday. And then I'll do the so now what segment, where I'm going to try to draw out some of the implications of Eric's discussion. This is a picture of Little Red Riding Hood, because I'm told that it's a cautionary tale in itself, roughly to the effect of don't talk to strangers. So one of my goals for today is to help us zero in on the nature of Eric's cautionary tale. Okay, so in the big picture, what was Eric's key message yesterday? Well, I think it was that causal inference in complex nonlinear systems is more difficult than we wish it was. And it's certainly more difficult than is convenient for us in policymaking. And when we are engaged in it, we're vulnerable to mistakes. And this has been shown in climate science and in epidemiology. So one of the first examples that Eric used was from climate science, where between 1998 and 2012, there was this observation of what seemed to be a hiatus in global warming. And as Eric described, scientists were eager to advance many different hypotheses about what was causing this. And as I've done here, we might visualize these hypotheses as the more attention-grabbing characters at a party. But the moral of Eric's story was that, you know, it's not always the attention-grabbing hypotheses that are the correct ones, right? And in the case of this observed hiatus in global warming, the best explanation was actually a discrete character, ordinary internal variability. So during COVID-19, many scientists have turned to the question of which population level interventions have been effective in curbing transmission. And I took the upshot of Eric's talk to be that there's no good evidence right now that any of these have been effective, and we don't know how effective if they have been, right? So once again, the observed differences could be the result of this discrete character.
Right. Stephanie, I just wanted to, and this wanted a clarification here for both you and Eric. And Eric, this is other than complete lockdown, right? So that was clear. Would you agree that would both of you agree that complete lockdown prevented transmission, right?
I'm going to tell you my interpretation of Eric's talk was that has not been shown well.
Okay, great, thanks. Yeah, I just wanted to insert there in the event that we don't come to that question. I wanted to make sure.
And I think I have a little quote from a paper that does go into depth about that, and we can definitely bring that up in the discussion. I certainly did not read Eric's talk as being, you know, that even that has been shown. But Eric's talk gives us this chance to go through some of the challenges that come up in addressing these types of questions broadly, right? So very often in population health research, the questions don't lend themselves to randomization. They don't lend themselves to randomized study designs. And that's either because they're not ethical or just because they're not feasible. So we need another way to control for confounding if we're trying to do causal inference. Now, one big class of techniques basically tries to exploit some source of arbitrary variation in who gets the treatment and who doesn't, sort of like across jurisdictions, across different regions and times. So Eric focused on two such methods yesterday, the first being the difference in differences method, and the second being synthetic control. So with the DID methods, basically we're trying to identify sort of a natural treatment group, natural control group, like a place that implemented a mask policy and one that didn't. And then, we're trying to compare them in terms of the change in the outcome before and after the intervention was implemented. And then with synthetic control methods, the focus is similar, but instead of using one or two specific real world control groups, there's a data-driven method for stitching together numerous control groups into one in a synthetic way. So basically identifying multiple control units that the analyst thinks, had similar characteristics, had a similar outcome trajectory prior to the intervention, similar to the treatment group, and then doing a weighted average. So the advantage of the difference in differences method is that in theory, it's able to account for confounding between treatment and control, as long as confounders are fixed over time. But the flip side is that we have to be able to assume that there's no sudden changes in confounders. So as Eric explained, this is called the parallel trends assumption. And it basically means that we have to assume that, without the intervention, the outcomes for the treated and the control groups, would have been following parallel trajectories over time. Now, the synthetic control, oh, no, for some reason I suddenly can't advance. Guy, do you know why that would be? I suddenly can't advance? Oh, I think it might be because of someone going in the waiting room. Any suggestions?
And I admitted that person. Let's see. Okay, maybe try now?
Yeah, okay, now I'm good.
That's funny. Okay, thank you.
So synthetic control methods have several requirements. I'm not going to go through them. They're all detailed in the Abadi article that Eric circulated. But the point that Eric was emphasizing yesterday was that among the requirements, there are two in particular that are sort of in tension with each other. So first of all, there need to be appropriate comparators available. So to add into this synthetic donor pool, there need to be available comparators that are, they have similar attributes to the treatment group. Now, second of all, there can't be interference in the sense of spillover effects of the intervention. So there can't be sort of a phenomenon where people are watching and they're seeing that the intervention is happening elsewhere and they're sort of taking it upon themselves to do it too. So yesterday, Eric put up a quote from Abadi, and I'll do the same here. So viewers can maybe pause the video and read this quote for a good explanation, summary of this tension that we're talking about. Okay, so in a nutshell, I think Eric was emphasizing yesterday that methods for causal inference have requirements. And it's risky business to be pretending that we satisfy those requirements when we don't. So that was the takeaway, I think. And I think we might understand this in terms of epistemic limitations, which is a big picture problem in population health research. And I want to connect this to an article from last year from a group led by Mathe. This was a review of methods that are commonly used in population health research, and they clustered them into two main strategies. So these are these instrument-based approaches, like the ones that Eric was talking about yesterday. And then there's the methods that are known as confounder control approaches. And their conclusion was ultimately that, all of these methods rely in one way or another on some unverifiable assumptions. And further to that, there are trade-offs involved in choosing what method to use. And ultimately, having different lines of evidence from different study designs is probably the best that we can do. They also made another note, which I think is important, which is that in their experience, researchers in population health, they tend to rely on one or the other method, right? And there's often a lack of understanding of the other method, right? Whatever method one does not specialize, there's often a lack of familiarity with how it works. And this can be problematic because to really interpret the evidence well in population health, one needs to understand the trade-offs that are inherent in the different methods. Okay, so there's limitations in our methods, but there are also limitations in our capacities, right? And I want to connect this to a paper that I think is relevant. I know it's on Eric's radar. So this is a critique that came out of a model that was focusing on the efficacy of different COVID interventions, or NPIs, right? And these authors write, we conclude that the model is in effect too flexible and therefore allows the data to be explained in various ways. And this has led the authors to go beyond the data in reporting that particular interventions are especially effective. And they say this kind of error, mistaking assumptions for conclusions, is easy to make and not especially easy to catch. So that's a point I want to put on the table. Okay, so moving on to the "so now what" segment, I think there are a number of different directions that we could take this conversation. And that includes ideas like, how can we overcome these limitations? But instead of doing that today, I want to steer towards some normative questions, because I think they relate to a number of themes that we see coming out in Eric's recent work, and particularly the 3 papers that he circulated in advance of the talk. So on the bottom of the screen here, I've put the sort of truncated titles of those 3 papers. And I just want to distill a few key messages from all of those papers. So first of all, scientific models, broadly construed, they're not sort of truth-apt things, right? They're evaluated in terms of adequacy for purpose. And this emphasizes that modeling is a value-laden activity, both because purposes are value-laden and so are our notions of adequacy. So there's a corresponding risk there. And that's the risk that modeling decisions that come up in the modeling process, and ultimately models themselves, are going to be inadequate for purpose. Now, Eric and I call this representational risk, and we distinguish it from inductive risk, which we take to be the risk of endorsing a false fact. So the argument there is that there's an advantage to understanding those risks as different, even though we might want to draw connections between them, and even though they both give us insight into the role of values in modeling and values in science. Okay, so third, Eric has argued alongside some co-authors that in certain contexts, our epistemic standards should actually be quite high. So for example, when it comes to restricting civil liberties, it might be acceptable to do this just on the basis of precautionary reasoning for a certain amount of time. But after a certain point, this ceases to be acceptable. And in the long run, governments are only justified in restricting civil liberties on the basis of good scientific evidence. So not just the best available evidence, but good scientific evidence, and also on a careful and transparent cost effectiveness analysis, which of course is another normative enterprise. And then the last point, in the cost of learning paper that he circulated, Eric offers up a framework to help us think about the expected net benefits of research. And this is taking into consideration that, monetary costs of research are not the only relevant costs. So Eric uses the term Ungoodian costs to describe sort of non-monetary costs of research. And he's given us some reasons to think that under some conditions, research could have a negative expected utility. So 2 specific examples of Ungoodian costs that I think are relevant for today. The first is the possibility that the results of research might be taken as being stronger evidence than we think is right. And so basically, if we think that decision makers are going to effectively misinterpret the evidence, then research could have a negative expected utility for us. And further to that, another Ungoodian cost might be something like negative externalities. So for example, maybe research is going to signal something that we don't want it to signal. And if that's the case, again, maybe research could have a negative expected utility. I think I'm going to have my same slide advancing problem, folks. Oh, there we go. Okay. So now that we know these terms that Eric uses, I just want to sort of riff off them and present an imaginary scenario to get us thinking about some of these normative questions. Okay, so first, for the sake of argument, let's just imagine a model where we all know that the requirements for causal inference are not met. So the model is not adequate for causal inference. Now, interestingly, it seems like one way to evade representational risk is to just say that the model has a different purpose. So I'm thinking of something a bit analogous to something that we've seen in COVID modeling, which is to basically say, well, the model wasn't for prediction. It was for conditional projection. So then if a model said something like, under conditions A, B, C, we would see X number of infections or X number of deaths. But then those conditions don't materialize, those outcomes don't materialize in the world. There seems to be no grounds upon which we can object. So when it comes to models that don't satisfy the requirements for causal inference, I think maybe we can imagine something or more than one thing that would be analogous to that. So for me, a few distinct possibilities come to mind if we go ahead and we build this model. So first, the model gets genuinely misinterpreted. It gets misinterpreted in good faith, maybe by policymakers or scientists from another discipline who think that causal inference is what it's for, and they use it for that. Second option, maybe the model gets used as a rhetorical device. So no one actually thinks the model can support causal inference, but doing it anyway allows people to advance their own preferred policies, and so they use the model to this end. And then third, we might imagine that the model just goes unused. So in other words, everyone recognizes the model's not for causal inference is what they want, and so they just move on. So I think at the very least, there's probably some waste of money involved there, but there might be some negative externalities too. So maybe in terms of what we signal to the public. And then finally, since we're imagining this, I think we need to imagine a few contextual factors that are probably relevant. So the first that comes to my mind would be the degree of epistemic opacity. So to what degree is it possible to know all of the epistemically relevant elements of this model? Maybe that degree of epistemic opacity would change the picture for us in some way. Second, to what extent are various agents directly engaging with the model and doing their own assessments of adequacy for purpose? Because it seems like in many contexts, it's actually a relatively small number of people who are really looking under the hood of the model, and a relatively large number of people who are just relying on epistemic trust. And in fact, this seems to be a standard feature of current, epistemically distributed research and policymaking contexts. Now, three, assuming that this is a policy-oriented model, to what extent do people agree or disagree about what counts as a benefit? So this seems relevant, particularly in contexts, like mask mandates. It seems like people deeply disagree about what should be counted as a cost and what should be counted as a benefit when it comes to wearing masks. So for example, if mask wearing affords me a level of perceived comfort, does that make it on the ledger or not? Beyond that, there seems to be some disagreement about what price we should be prepared to pay for what level of benefit. So even, for example, let's say we had perfect knowledge that masks cause a 5% reduction in COVID infections. Would that mean that we should implement a mask policy? So it seems like there's at least not good agreement there, or not good evidence of agreement. Finally, I think we should just get it on the table that, again, people do say we need complementary evidence from different study designs to support robust causal inferences. So maybe there are some of us who would carve out a role for models that they don't allow causal inference themselves, but maybe in some way they would help us reason things out down the road, maybe, or possibly in combination with something else. Okay, so this leads me to pose Eric a few direct questions, and maybe he can pick, which ones interest him. So first, I'd like to know if you think it's legitimate to assign a causal model a different purpose to evade representational risk? Also, do you think that there are conditions under which models of complex linear systems would maybe have a negative expected utility? Finally, sort of a two-part question, can we do a better job of articulating epistemic standards in modeling for causal inference? And then what about epistemic standards in the policymaking context? So on the latter points, I am thinking about a couple of things in particular. I'm wondering, do we need to specify the model purpose in advance? Does it need to be done in a particular level of detail? Do we need to spell out what are legitimate purposes for models? And do we need to set standards around who should be involved in determining whether a model is adequate for purpose? So those are just some ideas to get the ball rolling. These are the references that I mentioned if anyone would like them, and I will toss it over to Eric.
Thank you so much. Yeah, thank you so much, Stephanie, for these wonderful comments. So Eric, please.
Can you put the question slide again?
Oh, yeah. I guess I have to press share screen again. Is that convenient for everyone?
Is that right?
Is there any disadvantage to my being the one that shares it again?
I mean,
No,
I think you have to. No. Okay, good. So, yeah, so the first question I think is tricky because I think when you do something like that, so in other words, the idea is like, could I take a model that looks like its job is to attribute causes to something, but it's not adequate for that, and then mitigate the damage of that by being clear that this is not what the model is for. One thing this makes me think of, just maybe I'll back up to climate. So in climate science, there's a kind of long-standing history of these things called the RCPs, the representative carbon pathways, I think is what it stands for, although I might have that wrong. And there's RCP 4.5 and RCP 6.5 and RCP 8.5. And pretty clearly, these pathways were picked, way back, I think in maybe the early 90s, maybe that far ago, I'm not sure. But there was the idea that RCP 8.5 was often called business as usual. And what it is, right? It's just a graph of carbon in the atmosphere from the present until the end of the 21st century. And it's pretty standard for climate models to run projections on these RCPs and show you this is how hot the world's going to be for RCP 4.5. This is how hot the world's going to be RCP 6.5, etc. Okay, so some people have sort of started to complain a little bit about the fact that RCP 8.5 is still often in the toolkit, even though it looks. Sorry, what? I'm getting a radio right back.
Could I just request everyone else to mute their microphones, please? That might help.
Okay,
I'm struggling to mute mine because I'm stuck on share.
I don't think you're the problem.
Seem to have a really weird. I'm not the problem? Okay.
I don't know, maybe not. Anyway, good. So there's been some people wondering why are we still doing 8.5? Given that it certainly seems as though the world has made enough progress that 8.5 doesn't really look like it's in the cards. So in other words, we haven't had the massive increase in carbon output that maybe people worried would happen in the 90s, and that's represented in RCP 8.5. And of course, it's a perfectly okay thing, and a lot of people say this. They say, look, these are just pathways. These are just storylines. 8.5 is just a storyline. We're not saying, there's no indication here that this is what's going to happen. These are not predictions. These are just projections. This is just like, if we were to do 8.5, this is what the world would do like. And I think there's of all the things that you get in the climate debate, I think that's one where there's actually some pretty honest debate that could be had about that, right? how confident ought we to be that when we put things like that into the public domain for consumption, that people will understand, right, that 8.5 doesn't really look like it's on the table anymore. To what extent should we worry that they're going to think, look, this we know that some vaguely in our, in the back of our heads, 8.5 is so-called business as usual. So when I see the projection on the graph that's being circulated by various climate scientists and various labs, why not think? Why isn't it reasonable for me to think that that highest curve is what I expect the world to behave like if we don't make major changes? So I think that that's a tough question, right? I think when you're putting a model out there and handing it to policymakers, not just handing it to policymakers, but putting it out there for public consumption as a way of and I don't think it's a stretch to suggest that both climate scientists and public health experts over the last year have been trying to influence public perceptions of what ought to be done. I think there are interesting questions there about whether it's legitimate to put a model out there that looks like it's doing A, but in the fine print, right? It's like, well, actually, we're not actually claiming that we're making causal inferences here. We're not actually claiming anymore that this is business as usual, et cetera, et cetera. I do think there's legitimate worries there that you're now drifting from your job as someone who, I take it, the standard line is your job as an epistemic expert is to provide us with the best information that we can get. Your job is not necessarily, right, to make a determination about what the best thing to encourage, the best thing to get people to support qua policy, because what the best thing to support qua policy is always, as we all know, is obviously, right, a combination of, right, what to believe and what to value, right? And so I think there's a fine line to be walked there about when modeling efforts like that, where a model is inadequate for some purpose, the fine print just says that we're not really using it for that purpose. But it sure looks like, right? Sure looks like for public consumption that that's the purpose it's useful for. I think there are issues there that of sort of that's a possibly sneaky way of breaching that line between informing people and sort of imposing your views of what the best balance of costs and benefits is. Are there conditions under which models of complex nervous systems have negative expected utility? Yeah, I mean, for sure there could be, right? I mean, so the phrase Ungoodian costs that Stephanie mentioned is just me kind of giving a more formal decision theoretic framework to a line of argument that comes from Phil Kitcher. And Kitcher was interested in the question of, when is it bad to do research into the natural natural differences in ability that exist between sexes and races? And he just mounts the argument that this is generally speaking research that's going to have negative expected utility because, right? Simply because when it looks like there's evidence that there's no difference in abilities, people tend to ignore it. When it looks like there's evidence that there is abilities, it makes every newspaper, it gets on, it blows up everywhere. And so there's a kind of much higher probability of the evidence being misinterpreted in one direction than the other. And then there's a much higher cost of being wrong, he thinks, right, on research. And I agree with him there, right? If there are differences and you wrongly point out that there aren't, probably nothing's going to happen anyway. But if there aren't differences and you point out that there are, you're going to cause an enormous amount of harm, right, to people by pointing this out. So so that's the kind of condition under which, like, you know, an evidence gathering practice can have negative expected utility. You know, look, over the last year, we have engaged in interventions that have been enormously costly to a lot of people in a lot of places. You know, particularly, there's, I think, been a phenomenon of the following kind, right, where, you know, public health experts in developed countries, particularly, let's say, the United States and the UK, have been trying to influence policy here and putting forth certain kinds of models that show certain, you know, benefits to interventions. And then those interventions have been tried in developing countries. I have in mind particularly India and South Africa, where those interventions were both wildly unsustainable, so they had very low likelihood of actually providing any benefit in the long run, and had just enormous costs, right? So we know about these things like, you know, these death marches in India that happened when migrant workers were just cut off from their jobs and their housing and their transportation. So I do think that when you engage in inference that you kind of know in advance that you don't really have good tools for getting reliable answers, you ought to think hard about what the possible negative expected utility of just gathering the evidence is. So I agree with Kitcher about that. Can we do a better job of articulating epistemic standards, modeling for causal inference? I mean, I think this is tricky. I think one of the things that makes it especially tricky is a difference between, this is going to be a mouthful, the difference between difference and difference and synthetic control methods. I think, you know, one of the features of synthetic control methods for causal inference is it looks like a magic trick, right? But if you read the sort of foundational papers, I guess I don't really know how to pronounce his name. Is it Abadi? Is that something like that? I'm not sure. Is it
Abadi?
Abadi, thank you. If you read like his foundational papers on this, he's quite clear, right, that doing synthetic control requires a lot of skill on the part of the person making the donor pool for the synthetic control method. And that if you don't exercise great care in choosing that donor pool, you can show almost anything causes anything else. So I think, you know, that difference in difference method, that synthetic control method has that disadvantage relative to a difference in difference method, that it really requires quite a bit more trust in the modeler. It's a little bit harder to look under the hood and see whether things have been done in a way that really does eliminate the likelihood of confounds there. Yeah, and what about epistemic standards in evidence-informed policymaking? I mean, look, I think we ought to be having a lot of conversations about this. I don't know what the magic wand is, but I do think that, you know, a lot of these, for all the reasons we've been talking about, a lot of these kinds of scientific work that inform policy can very quickly look like they are evidence for a policy choice, right? And I think if you go back and say, look at like Report 9 by the SAGE group in the UK that came out, I think, March 19th, 2020, right? This was probably the most influential scientific report in the history of the world. I don't think that's an exaggeration. It very much reads like, you know, an advocacy for a set of policy choices. And it's, I think, quite clear that those policy choices involved balances of costs and benefits that for whom the stakeholders were literally everybody in the world. So yeah, I think that it's important that we, in some way or other, and I think we need to be having a lot of conversations about how the best way to do this is, and I don't have the answers, but in some way or other, we need to be, I think, thinking about the ways in which, when research like that is being done, you know, that process of sort of the ways in which values are entering into the scientific inference itself are in some way or another, getting at the representative values. Because I think one thing that I've sort of had the growing feeling of over the course of the last 14 or 16 or whatever months, however many months it is now, is that, a lot of the policies that we've been advocating have been really good for the kinds of people that do the kind of scientific work that goes behind the policymaking. I mean, there was this stuff in science studies that was quite popular in the 1980s called interest modeling. And the idea was it was in sociology of science. The idea was you explain every episode in the history of science in terms of the scientists just reached the conclusions that were good for them. And the classic case was 19th century Victorian work into eugenics, right? That was the typical example of interest modeling. And I at the time I didn't wasn't a big fan of that stuff. And in general, I'm not necessarily a big fan of that way of thinking about the history of science in general. But it's felt pretty strongly to me over the last year that we have instituted policies over the last 16 months that have effectively diverted the virus away towards everybody but upper middle class knowledge workers. And I don't think that's a massive coincidence. So I think I think that is the money question. Stephanie's last question on the slide here, but I don't know what the answer is. But I definitely think this is a crucial thing to be talking about if science is going to be informing policy. Is how do we make sure that the epistemic standards being used in that scientific work, are representing the values of all the stakeholders? Because it's pretty clear to me, at least, that what we've seen over the last several months has not been something where the science has been done in a kind of cool, dispassionate way that is just being informative, so that then policymakers can. That's our standard picture, right? The scientists are supposed to just give us the information, and then the policymakers are supposed to represent the interests of their stakeholders and combine those interests with that knowledge and pick policy. That first part didn't, I don't think, played out that way this year. So I think it is time. I think it is, we need to be having more and more of that conversation. Okay, I think I'll let other people jump into the conversation.
Thank you so much, Eric, for that detailed sort of response and engagement with some of the really important questions that Stephanie has raised. So I think I wanted to take the liberty of sort of opening up to the floor with a question myself. And and I think I wanted to come back to this idea that both of you have touched upon, which is the purposes of modeling, right? And clarity about the purpose of modeling, and that it's almost that the purpose that you are modeling either to make predictions for practical reasons in terms of resource management. In the case of COVID, it was to ensure that there are enough hospital beds in particular cities and regions. So that was sort of driving that kind of resource availability, and assessment was driving it. I was curious about what you both felt about how do we present the motive for modeling in a more clear-cut, transparent way. I mean, there are, of course, always going to be people with agendas who will want to read into it, no matter how you state what your purpose is, how clearly you state what your purpose is. But I was wondering if you both had some thoughts about, how could we have a bit more transparency in at least the motives for, a particular model and the presentation of a model in a particular way.
Eric, do you want to go first?
No, I thought maybe you'd take that one first.
Okay. I do have some thoughts on this matter, particularly in health economics, because very often people will talk about models in health economics as being for the purpose of prediction. And in fact, one of the major guideline documents about health economics modeling has a line that happens to get me a little worked up, which is that ultimately what matters is that a model reproduces what happens in reality. And I'm only paraphrasing very slightly, right? And I think that in a lot of contexts, we're not going to get there, right? And Eric, I imagine that you agree, right? Because what we're trying to do is predict a system that probably defies prediction really at any meaningful level, right? Particularly in the context of, for example, very often, particularly in Canada, we do 2 clinical trials to evaluate a new drug, and then we do simulation models to try to anticipate what the costs and the benefits are going to be to the health system of making this drug available to the public. Now, we all know the limitations of randomized controlled trials, right? They're conducted under conditions that are not like the ones that exist in the real world. So to just imagine that you're going to be able to take that evidence and put it into a simulation model and have a good grip on what's really going to happen, I don't have a lot of confidence in that process. Further to that, I think to be able to make meaningful predictions, you'd have to have a way of testing whether they panned out, right? And we don't really do that, right? In the Canadian healthcare system, once they invest in a particular drug, they don't do rigorous studies to say, okay, well, now that we've invested in it, what has happened, right? So in my own opinion, I don't think it's quite right to say that the purpose of those models is prediction. I don't think that's well put. I think it's better to say that the purpose of that model is to inform decisions, right? And I think the next step then is to talk about under what conditions people are wanting to make decisions and what their attitude is to uncertainty. Because there are some really important normative questions that need to be answered there. And there's the dominant line of thinking in health economics that basically says, you should just not mind uncertainty, and you should go with what looks like the best bet, turning a blind eye to the uncertainty that you have. And, some folks might agree that that's the best way to do it. I don't happen to agree, which I think underscores that that's actually kind of a moral judgment, right? So I think that we need to actually do a better job of articulating the purpose of the model, do a better job of fleshing out our relevant attitudes, and then having more public debate around how we want to do this, because you could probably do it in way more ways than we're ever even getting on the table.
Right.
I just want to add one quick thing to that, which is that I just don't even get the idea that the purpose of a policy guiding model is prediction. Because after all, policy choices are always choices between at least 2 alternatives. And so just being able to predict what happens under one particular policy choice is totally uninformative. I need to know what would have happened under the other possible policy choice, and that's not prediction. I've had a few debates about, I'm sort of well-known, I get hysterical about the Imperial College model and Report 9 and the SAGE group. And so people like to point out, they actually predicted the course of the epidemic rather well in certain countries. Well, yes, they predicted it really well in the countries that followed their advice, because in their model, they vastly overstated the fatality of the virus and vastly overstated the effectiveness of the policies that they recommended. So obviously in places where people followed exactly their policy, those canceled out and their predictions were great. But their predictions for, let's say, Sweden or for Florida and were bad, and their predictions for developing countries were horrible. And it's not, to say, oh, well, we predicted what was going to happen in the UK reasonably well. That's totally uninformative. I want to know what your the full spectrum of your counterfactual projections was, because that's what informs policy. Predictions don't inform policy. But yeah, and then I agree.
Yeah. Yeah. So I think thank you both. I think that they perhaps one way to have seen these predictions that were made is simply seeing them as maps of possibilities. And, and I think the problem with narratives, public narratives, is that because people don't really understand what inherent uncertainty means, and what a lack of knowledge evolving, sort of the provisional nature of figuring stuff out about the virus itself was hindering us from really getting a grip. I think that, what might have been useful was like, a map of potential scenarios, and then discuss policy interventions in the context of a range of these projections, and not, as you all said, to fixate on one and say, well, how can we, but I wanted to come back because Stephanie brought this up, and a little bit of clarification, and from your experience and expertise, my impression as a person who works in a field where, we don't really do randomized controlled trials, but, I sort of follow it because they are seen as the gold standard and so on. And in astronomy, there are people who aspire to do randomized controlled trials in terms of selecting image identification and classification and so on and so forth. But to the technique itself, isn't it true that the whole methodology assumes that you have independent, non-interleaved causes and that you can therefore isolate them? If you have compound causes, and if you don't know what all causes are possible, RCTs are no good, right? I was just curious, what are really seen? Do people in health in particular, because that's where these are sort of the gold standard, are the limitations of these techniques also being sort of actively studied now?
I think definitely the limitations of RCTs are more and more attended to. And in particular, I think the language gold standard is definitely on the way out. I think there are definitely people that still use that. But I could be mixing up my fields here. I know philosophers of science do not use that term anymore, and they have good reasons for not using it. So there are, again, like a few assumptions that we have to go on if we're going to regard RCTs as being extremely, if we're going to use language like gold standard, it's because we think, all the confounders are randomly assigned, they're not affecting things, right? And of course, you can't ever prove that. It could be the case that there are confounders that you're not measuring and they weren't randomly, they didn't happen to balance out, right? Randomization probably balances it out, but it doesn't ascertain it for sure. But I think the thing to focus on even more is about this, again, what is the purpose of the randomized controlled trial? And in what respect does it not suffice for purposes that actually we deem very important, right? So the RCT is answering a different question altogether. It's answering this question, if, for example, in the context of a drug, does this drug work under perfect conditions? That's the question. And at some point, the relevance of that question expires. And we're not interested in that anymore. We're interested about whether it's working for us in the real world. And then we really get into a lot of challenges because we're into this, well, now we're in the real world and there's all sorts of crazy stuff going on and we don't know what we have to control for. And it's very different types of folks who are taking those drugs, and we lose track of, are they taking it as prescribed? Are they interacting maybe in other things they're taking at the same time? And so on and so on and so on. So yeah, I think it really does underscore that we have to understand the different purposes, and as well we have to understand our limitations, because it's true that once you bump into that observational study context, then you're facing all the problems that Eric and I just went through in terms of, well, now you don't have that benefit of at least randomization seems effective for maybe balancing out confounders. Eric?
Just real quick, I'm just basically summarizing what Stephanie said, but look, randomized control is great. It's a great thing to be able to do, but it also imposes costs. Like, suppose you wanted to do a randomized control on the effectiveness of masks, right? You could do that. Let's say you got around certain ethical, issues on that, and you did it. Well, what would that look like? Presumably that would look like you'd get a bunch of people, you'd make some of them wear masks, and you'd send them into certain controlled conditions, and then see how they compare to the people who didn't wear the masks. Now, you're going to eliminate a lot of confounds there, right? You probably eliminate all the confounds, but you're looking at a very narrow set of circumstances. You're not then seeing whether, you're just determining what mask use does in this very narrow, constrained set of circumstances that your trial is taking place in, which might not be that informative about what happens when people are expected to wear masks for 8-hour shifts, or children are asked to wear masks in schools, or, et cetera, right? You can't possibly do an RCT in which all of the sort of in the wild phenomena are being studied.
Right.
So observational studies do have a number of advantages over RCTs because they do take place in the wild. But of course, then they have all their confounds, et cetera, et cetera. So there's no magic bullet.
Right, and I think that, as you said, in this kind of mass study example that you just gave, I mean, the idea that you are marginalizing over all other variables, even in a controlled study, is clearly absurd, because two different people with different genetic, physiological, underlying proclivities, conditions, are going to react differently to the same level of exposure or lack thereof, right? And so we know that already. We know that about all our bodies, that there isn't one metric that can represent any kind of risk X, because the marginalization over all other variables just doesn't work. I mean, it really doesn't work. I think we should move on to the questions, and I would like to first cede the floor to sort of two questions from Chris, who has been engaging with us offline as well. And so he says that he has two questions that are similar to the third question that Stephanie raised, which first, that policymakers are faced with a comparative assessment. How do we compare models with other sources of evidence regarding the effects of policy interventions? They could still be the best of a very bad lot of possibilities. Second, looking forward, how could we do better at drawing these kinds of causal inferences? Are there different kinds of data that public health agencies should be gathering, for example?
So I'll start with the I'm unmuted. I'll start with the second question, because I think that's a little easier. So the second question, I think there are two things that I've been sort of pressing for over the last several months. One is, I think we did too much changing our mind about the received wisdom over the course of this pandemic. There were a number of, sort of standard procedures in the CDC for doing things. And they said things like, don't close schools for more than 6 weeks. Et cetera. And we very quickly decided in this pandemic, I think in part because we were watching what looked like we thought we knew was going on in China. We thought, like, this is so different. We need to just rip up the playbook, and we need to just be making all these wild inferences on the fly and guiding policy with. And I don't think that was super wise. I think science is done. Good science is done slowly, and it's done with peer criticism, and it's done with stakeholders having voice, et cetera. So that was part of it. And then, early on, also very early on in the pandemic, I think we were doing a lot of modeling with very poor information about what the outcome of the virus was in different age groups, et cetera. And that was an easy fix, right? We could have been doing a lot more, serology testing to figure out how many people have been infected. It's kind of a scandal. I think that I obsess over this stuff, and I don't really have a good feel for how many Americans have been infected with COVID. I think it's probably somewhere between 100 million and 150 million, but probably the uncertainty gap is wider than that. That's where I put mine, and already that's appallingly large. We just should know more than that. We could have known more than that. We could have been doing a lot more spot testing, random spot testing, doing more serology testing, getting a better feel for how many people have been infected, which would have given us early on a much better sense of what the danger of the virus placed on different age groups, which might have had us adopting quite different policies with respect to schools. I think in the developed world, I think the way we've handled schools has been pretty appalling. There was a really good piece in the New York Times last week that I'll try to share at some point. I think everybody should read, just about how scandalous the way we've handled schools in this country has been over the last year and a half. So that's I think that was your second question, Chris. Your first question was, what do we do when it's the best out of a bad group of models? I think this gets to Stephanie's question about like, when does research have negative expected utility? And I think the answer certainly is sometimes. I think sometimes the best science out of a bad lot might just be better left not done, or at least not paraded around, right, in a way that suggests it's but I mean, we've had a lot of rhetoric in the last year and a half about how various policies are following the science. I mean, that certainly makes it sound like two things. One, that there's very little uncertainty in the science, and that was crazy. And second, that there's like some deterministic mapping from what the output of the science is to like what the right policies are, and that's also crazy. So yeah, I don't know, when you've got the least bad method available, what should you do? I think that's a tough question, and I think when that happens, all of the things Stephanie was talking about public participation and about including, I think the more uncertainty you have, the more you're selecting from the least bad model, from the least bad method from a barrel of bad methods, the more you need to be paying attention to the fact that you're in grave danger of putting forward both knowledge and recommendations of policies that favor some stakeholders over others.
Thank you. Stephanie, did you want to add anything?
I think I've lost the nugget that I would reply to. So maybe we should move on to the next one, and I'll weigh in on that one.
Okay, great. So the next question was by Sanjeev Kumar on causal discovery and the extent to which it is about the search for right counterfactuals, and that it is largely a social process. So the role of mentors, communities, connections, and networks. So is this social learning aspect that does not get sufficiently emphasized as a way nonlinearity gets factored in? And this may not be amenable to modeling at all, but we do need to acknowledge it. And what are your thoughts about how to take that into account?
I guess I'm not exactly familiar with what the question is talking about. Stephanie, is that?
I'm going to take a stab at replying to that, and if I'm off the mark, just let me know. I'm unfamiliar with some of the terms in that question, but the part that I think I'm picking up is really important, has to do with the fact that you do not have to model every question. And I think that's exactly right. And I think that like part of what really interests me is having more open conversations about like, what is it that we want to model? Like when we talk about ourselves as a community, insofar as is possible, like which questions do which communities want to approach with a modeling strategy? I think it's wrong to be pretending that every single question has to be approached in this fashion. And it does connect to what Eric's talking about in terms of the negative expected utility of research in certain contexts, right? So for example, I think sometimes we find ourselves facing a problem that it is very new. It's going to take some time to figure out. And maybe we do want to assign some scientists the role of slowly figuring that out. But that doesn't mean that we don't have to figure out policies for now, for the interim, right? And I think that it would be okay in some contexts to say, okay, as a community, what are we going to do? We don't have good information right now. Let's acknowledge that. And let's just think about what our goals are and see if we can get on the same page about what we really want to achieve and whether we can come up with strategies to achieve those goals that allow us to avail ourselves of information that we think is really good quality, okay? And I'm thinking in the context of health, like there's a whole debate about what health even is, right? And if we want to achieve, like in COVID, ostensibly what people are really worried about is people's health, right? Well, there are lots of things that society drops the ball on all the time in terms of failing people's health, right? But that doesn't mean that because we have poor information about how to maximize people's health, right? So without having, and don't get me wrong, I'm not trying to take this too far, but there are simple things that society wasn't doing prior to COVID anyway. And it might have made sense in some more moral conversations to say, okay, well, we have a pandemic going on. What are some strategies that probably, regardless of uncertainty, we could feel good about pursuing? Could we feel good about pursuing more sick days for people? I think you could come up with a conversation that was really just normative in nature that said, yes, in this context, I think we can feel good about investing in sick days. Maybe we can feel good about investing in strategies to make sure there's not overcrowding in certain areas. So those are just some questions that I would bring up, like in terms of, if we, in some contexts, want to shy away from modeling, what would replace it? I think some public deliberation could go some ways.
Right. No, thank you. I wanted to move on to the next question, which I'm going to have to interpret a little bit, and that I think has to do with how do we build and construct epistemic trust?
Yeah, we got a lot of bridges to fix, I think, about epistemic trust. I think, look, part of the reason I brought up some of these somewhat silly causal inferences yesterday, things like, that the motorcycle rally caused 35% of the cases in the United States over the course of 2 weeks, that, that Trump voting counties were the ones where there were the most COVID cases, et cetera, is, I mean, this is incredibly, people aren't stupid, right? I mean, people aren't rubes. People know that the wool's being pulled over their eyes with stuff like that. And it's incredibly, I think, damaging to scientific trust to engage in that stuff. And it was an election year. People were very passionate about this last election for reasons I understand very well. But it was alarming to me, I think, that people were willing to sort of throw scientific trust under the bus for that. I don't know what we can do. I don't know what we can do to repair it. Stephanie, do you have any thoughts?
Yeah, I mean, I guess I feel somewhat well, I don't know if optimistic is the right word, but I think one of the strategies to invest in is more public participation in science. Of course, this has been said by many, many, many people, but I think that it takes on an additional importance when it comes to this really complex modeling that's going on. I happen to work in more than one initiative that this is the goal, right? Is talking to folks about modeling going on. And I've met a lot of people who the knowledge isn't even there that those are techniques that are being used, right? So I don't think that's right. I think that they have a huge influence on society, and that it's not right for science as an establishment to sort of just take off at high speeds and do a lot of this problem solving using these strategies without making that additional effort to engage with publics and say, hey, we have these strategies that we're using and this is how they work. And one of the things that I think is important is that when you're given a chance to explain your methods to lots of different people at lots of different levels, you can actually force yourself to look at some challenges, right? Because you can get some tough questions. Oh, well, how do you show this? Oh, well, actually, we can't. We have to rely on this assumption or that assumption. And those are the types of conversations that, I mean, I don't know. I'm not an expert in what exactly builds trust. But speaking from my own personal perspective, when I talk to scientists, I really want to be able to know that they can tell me what it is that they're doing and be honest about, like, where is it that we're having to make assumptions and what are the gaps and so on. So I think there's a huge push to be very, very fast about a lot of things. And I think some of the solution is probably down the road of being a bit slower.
Yeah. Thank you. So moving on to the next question. The question is this is Ted Poston, and he wants to pick up again on the role of knowledge of causal mechanisms in connection with Eric's skeptical argument about inferring causation from the data exhibited by nonlinear systems. So he says that he worries that the argument proves too much. If it's difficult to infer causal relationships from data, as for example, the global warming hiatus example, then it's difficult to infer causal relationships from climate data of the past 100 years. The last 100 years is a blip compared to the millions of years of climate data. As climate warming skeptics argue, there are blips over many years in which the Earth warms and cools. Perhaps we find ourselves in a warming blip. The reply to this line stresses that we shouldn't rely on the data, but our causal knowledge of the role of CO2 in the atmosphere. Yet, if that's the correct response to the global warming skeptic, then it seems a defense of masking and social distancing can rely on our knowledge of the causal mechanisms of how respiratory diseases are spread. So the general issue here is whether we are ever in a position to infer a causal relationship with data from nonlinear systems in the short term, perhaps without the entire historical data set, without some background knowledge of causal mechanisms.
Good. So let me start with the climate case, right? I mean, I think it would be a mistake to think that the reason that we think global warming is happening is merely seeing the data and knowing that carbon dioxide is a heat trapping gas. Because after all, right, heat trapping gases produce feedbacks in the atmosphere, right? When the atmosphere warms, that releases more moisture. Moisture is also heat trapping. It creates clouds. Clouds are sometimes heat trapping, sometimes heat releasing. It changes the lapse rate in the atmosphere. That is, you know, could be heat trapping or heat releasing. That's a complicated question. It melts ice. Ice creates albedo. So there are all these feedbacks, and we have, you know, I think we have a pretty detailed understanding of some of that. We don't just have like, okay, here's a simple mechanism. Okay, now, so let's take the idea that like, well, what do we know about the mechanism of like viral transmission? Well, it's actually pretty complicated, right? I mean, viral transmission is fluid dynamics, really, right? And I mean, so it's not, you know, some of the people who were the most expert in this, right? I mean, this will be another link I'll share when I get a chance. Some of the people who were most expert on this were warning early on, you know, these cloth masks don't, like, if we are based on our understanding of the mechanism, these cloth masks are not likely to work, right? Because everybody who's worn one knows immediately if you wear glasses and one of these masks, they fog up your glasses. So just saying, okay, we know that, we know viruses are things that get exhaled from the mouth and nose. Therefore, if you cover your mouth and nose, that's enough knowledge of the mechanism to then know that, you know, this is going to be an effective method. In fact, a lot of the people with the most expert knowledge of that were warning early on, let's not give people too much, you know, of course, you know, the thing about masks, of course, was nobody, because it was such a sort of, you know, mild intervention, nobody wanted to be like, oh no, this is terrible, don't do that, because, you know, but I do think a lot of people were trying to warn, don't think this is some kind of magic bullet, right? Don't think that this can substitute for spending less time indoors with other people. And so, you know, the mechanism there is complicated. And in fact, right, some of the people I think were most knowledgeable about the sort of, you know, airflow and all that were kind of raising alarms about this early on. And in fact, they were in effect trumped to some extent by some of these causal inference methods. So it's a complicated story. The whole mask thing is a complicated story. And I think one of the things that really complicates it, and I'm sympathetic to this, I mean, I really am, you know, one of the things that complicates it was it's like, look, this is such a small ask, right? We're just asking you to put a piece of cloth over your mouth. And so I think that the dynamics of that were complicated. But if we're just thinking about this sort of, you know, coolly and dispassionately from the point of view of scientific inference, I don't think that the sort of, you know, physical mechanism reasoning there was really that good for thinking that cloth masks were effective. After all, you have to be able to breathe through them, and can't just, you know, it's not like putting a plastic bag over your head. So,
Stephanie, did you want to?
I think I'll leave that one to Eric. I have no expertise in climate science, and I think I would end up just repeating myself in terms of, you know, the message that we do have to have some conversations about decision-making under uncertainty, given that people are just going to have different takes, you know, about when we're going to conclude that something is one way or the other, right? Like there are always going to be folks that are like, I don't think that, you know, anything causes global warming that humans can control, right? There's always going to be some of those folks. So I don't know, I think I would end up underlining that again.
Right, thank you. Ty, did you want to see if there are any further questions?
Sorry, muted. Okay. I think you answered Sudha's, right? Lakshmi's question about complete lockdown, Priya?
Yeah, that's not a...
Okay, and
I
don't think we had Jenny Wagner's question in, did we? Does it help to decide which subsequent intervention to take when already having had an intervention in order to fix some initial conditions to make evolution models less complex? That was towards the beginning of the chat. Let me see if I can copy it. I'll copy it and put it down.
I guess this was about the purposes of models. It was relevant to that set of questions earlier.
Sure. Look, I mean, there's a very simple, like if you're trying to fix something, you're supposed to do one thing at a time, right? Like let's say, you know, your computer's not working, right? You know, jiggle this cord first, see if that works, then set that down, jiggle the other thing. If you're trying 6 or 7 different interventions all at the same time, it's going to be hard to pull apart, you know, which ones are working or which ones aren't. That's an added level of complexity. If there are sort of, you know, every place is trying all these different interventions all at the same time, it makes it very hard to figure out. If you think that as a group they're being effective, maybe which one is working, that's extra hard. I take it maybe that was the question, I'm not sure.
So then there's another question that's just come up, which is, you know, the relevance of the concept of contingency as a way to not evade the representational risk. So that's an interesting. What is the relevance of the concept of contingency?
You'll have to say a little more for me on that.
Francisco, did you want to type a little bit more explaining what you had in mind? Let me see if they're still there and might unmute them.
I think I'm thinking in the concept.
Well, let me unmute. I've asked to unmute them. Let's see. Ty, could you unmute them?
Yep. Well, I can only ask him to unmute, so I'm doing that. Okay, he's added a few more lines. You see it?
I have to say I don't quite get the connection. So he's thinking in the concept of Stephen Jay Gould's structure theory. Yeah.
I'm not thinking of anything brilliant to say back to that, unfortunately. Okay. Sorry.
So are there any other questions? Does anyone else have any other questions? Please feel free to type before we wrap up. So I think there's one question that's just come up that has to do with something that came up yesterday in your talk, Eric, and it's about the Abadi's dilemma as it arose in Jaina. I took it that one of the horns was the worry that if you are comparing Jaina to places similar enough to Jaina to make for good comparisons, then they may also be influenced by mask mandates in Jaina. My question is, can this lead to mistakes in either direction or only underestimation of the effects of mask mandates?
Well, I'll just tell you what I think typically happened, right? And you can see this in spades in the in the South Dakota case, in the motorcycle rally case. So what they did in a motorcycle rally case, they said, oh, well, we want to be, when we pick our control for South Dakota, we're not going to use any neighboring states because that might involve bleed over from people leaving on their motorcycles. And so they went with, they went with faraway states, and that gave them like a lot of flexibility. If you look, I've been trying to piece this through since yesterday because it's been a while since I looked at that one, but they ended up using quite a bit of Hawaii in the donor pool for figuring out what the synthetic control for South Dakota was. Now, obviously, right, that in that case, what's that going to do? That's going to make it look like the motorcycle rally, had a large causal effect. So I think to some extent, right, when you have those two constraints or two desiderata, right, one that says go look far afield. When you go look far afield, it just gives you flexibility, right? So that if the researcher is then either not careful or has an axe to grind, it just I think opens a pathway to either overestimating or underestimating, depending on how you pick the donor pool. Does that kind of answer your question?
It does. It just makes me wonder how things change if you go in the other direction. So if you compared South Dakota to similar states, then there'd be a worry that, like you say, maybe there's bleed over. But then it seems to me that would mostly create risks of underestimation of the effect. So if you still found a big effect, that might be informative.
Right. Typically, in my experience, having looked at a bunch of these synthetic control methods, they were all erred in the other direction. So yeah, I imagine that's probably right. If you erred if you erred in your direction, you'd probably be risking underestimating the effect. And I think that's why right, over all the ones that were at least being accepted for publication, it was usually like, look, we're showing this really pronounced effect of the intervention, and we're doing it by being really careful to go look far afield. And of course, as we all know, like after having watched the epidemic go for 18 months, I think most people can recognize that allowing yourself to look far afield geographically just allows you to construct synthetic controls that could sort of show anything you want them to show. Like if you can use Hawaii as a comparator for South Dakota, then,
right.
I think all bets are off.
Great. Looks like there are no further questions. So I would like to take this opportunity to say thank you to both Stephanie and Eric for this wonderful conversation. And, many complex ideas that are going to be quite hard, but very important to address in what we are really trying to do with modeling, be it in climate science or in health economics. Thank you both very much for these wonderful perspectives. And thanks everyone for attending. We look forward to seeing you all at the next convening, the July convening of our Inference Colloquium speaker series. And our speaker will be Professor Elise Crow from the CCNY. So thanks everyone, bye, and have a lovely weekend.